Yeah. Okay, well, we have this problem. Here's your f of x, here's your g of x. Okay, f circle g of x is just the same thing as f of g of x. And it's a little easier to see the substitution if you do this. Okay. Now, f of x is the square root of x plus 4, right? So f of g of x is the square root of g of x plus 4. Now, this is the way we look at it. It's not the way necessarily that everybody would most naturally look at it, but it's the way I find gets the best results on the average for class. So if you got a different way of looking at it and it leads you to the same conclusion that this does, that's fine. But see, f of g of x means replace x by g of x. And when we replace this x by g of x, this is what we get, isn't it? It's a straightforward replacement. Okay. And that equals then, since g of x equals 2 to the x minus 3, this is 2 to the x minus 3 plus 4. Now, there's nothing else you can do to this. There's no way to simplify this. There's nothing that if people are crossing out the x minus 3. And I'm not sure what you're thinking, but the x minus 3 is in the exponent. It's not multiplied or divided by anything, okay? It's not added or subtracted to anything. It's stuck there in the exponent. It applies to 2, okay? So that's it. So it's a very simple one-step process. Okay. Now, g of f of x. And of course, this is g circle f of x, which is the way I stated it. This is g of f of x. Make sure I'm on the board or on the screen here. Not sure. Yeah, you got it. Okay. And that equals what? Well, g of x is 2 to the x minus 3. If x is replaced by the expression f of x, then this x gets replaced by the expression f of x. So this is 2 raised to the f of x minus 3. Okay. Then we know that f of x is the square root of x plus 4. So this is 2 raised to the square root of x plus 4 minus 3. None of that can be simplified. Now, actually, using the laws of exponents, you could write this, and I guess this is worth looking at. I'll put this in parentheses. This equals 2 to the minus 3 times 2 to the square root of x plus 4. A bad place on the chalk or something to make the x plus 4. That's a to the b plus c equals a to the b times a to the c. This is the rule of exponents that tells you can do this. Okay, so this is the one bit of simplification that would be possible. And of course, 2 to the negative third is 1/8, so this could be written as this over 8. We're not going to go that far because really what we're looking at right now is just the process of forming a composite. Okay. Now there's another thing, and that's the domain and range of the composite. I'm going to mention to you. Let's take this expression. Is there any value of x that wouldn't work here? Well, what do you know about powers of 2? Now, I can say, just go since, well, from what you know about powers of 2, from what you know about the 2 to the x function, it's always positive, isn't it? I mean, x might be negative, x minus 4 might be a big negative number, but the graph does this. It's a graph that you're familiar with. And think about that graph. Every time you move 1 unit to the left, the value of the graph becomes 1 less, or it becomes half of what it was. And you keep taking half and half and half. It never gets to 0. So the basic property, one of the basic properties of powers of 2 is they can't be negative. Matter of fact, no power of any positive number can be negative, okay? And that goes back to the rule that says 2 to the negative x is 1 over 2 to the x. That's still positive. Okay? Now the point is then, since this is always positive, and this is a plus 4, then what's under the radical is always positive. Okay? And I think you might have seen a discussion about the fact that when you take a square root, you can only do it for positive, or you can't do it for negative numbers, okay? The reasoning here is this can't be negative. The 2 to the x minus 3 plus 4 can never be negative, so you can always take the square root. That's what it comes down to. So this function works for any value of x. And what you say is the domain of this function is all positive numbers. I mean, all real numbers. Okay. There's a tricky thing about the domain of this function, and it's simply that you can't take a square root of a negative number, and if x is less than -4, this will be negative, right? So that restricts the domain. And there's the range and so forth. So we'll get into deeper discussion on that in next week, I think, probably in the pre-calculus class. Just want you to have a little preview of that. And I think one of our students isn't here today, but we still have to address everything. And unfortunately, I still don't know exactly where that class is right now. So make sure we understand all this. Okay. Now we want to talk about transformations. Oh, heck. I mean, shucks. I mean, doggone it. Okay, well, I'm going to say all that now. I really need a better screen over here. Okay. What I've shown is that if you have the y equals x squared function, then I draw this just inside a 4x4 box here, where the x goes from -2 to 2, and the y goes from 0 to 4. This is convenient for the squaring function because we know that when x is 2, the squaring function gives us 4, so we have the point 24. And when x is -2, we get the point -24. So the squaring function fits nicely inside of this square. And the square is an aid to transforming the function. Okay, so what we can do is we can transform this function by moving the whole box 1 unit to the right. Okay, so if we move the box 1 unit to the right, well, the point here at -2 will go to -1. The point here at 2 will go to 3. That's 1 unit to the right. We can verify that if we move the square over from here to here, it's been moved 1 unit to the right. And we don't mess with the height of it. So as a result, the point -24 becomes the point -14. And the point 24 becomes the point 34. Now the equation no longer has the formula y equals x squared, and I claim that the formula is y equals quantity x minus 1 squared. Okay. Now, giving everybody a little time to plug that in. If you plug in x minus 3, do you get 4? I mean, if you plug in x equals 3, do you get 4? Give me a thumbs up if you got 4. Okay. Okay, I need to take a look at what everybody's doing. Okay, now we got a little cross-fertilization from people who are in my section of the class that already know how all this works. But we still have to do this for people who aren't in my class. Okay. I've done something very weird with my class, but I think it's maybe working. We'll see. And there's evidence that it's working because one of the people in my class pulled out all the heavy machinery I've given you in my class and tried to answer the question with that. It didn't work, but it was kind of impressive. Okay, so, but what we see is, I asked, if x equals 3, what do you get when you plug in here? That means you replace x by 3. And you get y equals 3 minus 1 squared, which is 2 squared, which is 4, which leads you to the point 3, 4. Okay, so at least for the point 3, 4, this formula is confirmed. If you put in -1, you get -1 minus 1 in the parentheses, which is -2, and then you square that and you get 4. So you confirm the point -1, 4. We have the point, this is point 0, 0. This would be the point 1, 0, right? If you plug in 1, you should get 0. Well, if you plug in 1 for x, do you get 0? Give me a thumbs up if you understand the answer. How 1 would give you 0. That's obvious, right? Okay, got immediately thumbs up. Okay, so that's good. And maybe you're just tired of me talking about this and want to go on. But seriously, that's not what you're doing. I know you understand this. Okay, make sure if you're watching this, if you're a distant student, if you're not here today, because one student isn't here today, it's kind of an important idea. It confirms, at least in this case, then that I've subtract my shift. I'm shifting this plus 1 unit, right? You know, add 1 to 2, you get 3, add 1 to -2, you get -1, add 1 to 0, you get 1. We shifted the graph 1 unit in the positive direction. But to get the function, we had to replace x by x minus 1. If you think about these substitutions, you'll understand why that works. Okay? Because there's always a temptation. If I want to shift this thing, say, plus 5 units, people are going to want to put a plus 5 here. But you know that's not going to work. Just try it and you'll see. Just do what I did here with a plus 5, and you'll find that it doesn't work. What works would be an x minus 5. That would shift the graph 5 units to the right. So here's a rule. We could move it 1 unit, we could move it 5 units, we could move it -8 units. If we wanted to move it -1 unit, we'd have to use a plus 1 here. And that would work. So to move any graph h units in the horizontal direction, we replace x by x minus h. Not x plus h, x minus h. Very simple rule. Okay. Then I can say, because everybody in this class has been through a unit on function notation. And this is addressing something I still see people in my class asking questions about, okay? And people are doing quite well in my class. We'll see how everybody did with the homework this time. Got a feeling a lot of people waited too late to start it. For any function, okay, this talk has met its match. I should have loosened up my shoulder. Dead center. Not that far short of the edge. Oh man. Okay. It was an easy shot. for any function, y equals f of x. Graph of y equals f of x minus h. If the h units horizontally getting hard to write down here. If the 8 units horizontally from the graph of f of x. Now, again, that's something everybody here is familiar with, but we want to make sure that the people who aren't in my pre-calculus section understand this. So that's the first rule for transformations. And in some ways, it's the hardest one to understand just because if you want to shift it plus 5 units, you got to remember to subtract 5, which means it's really good to understand this function. So for example, okay, so I'm going to ask everybody to do is write out what f of x minus h would be for each of these cases. Give you a minute to work on that. I'm going to clear off a little bit of board space, and I'll take a look at what you've got. Okay, now, as I said, people seem to have a little trouble getting started on this. Let's look at the problem, okay? So let's focus on what I'm saying here for a minute to make sure you understand what the problem is asking, okay? And that's a problem that I kind of anticipate people would have had with some of the problems on the homework in my pre-calculus class this time. So I use this terminology and this notation, and people have a little trouble sorting it out and reading what the problem means, okay? So let's just talk about this problem. Let's say, what's my instruction? It says find f of x minus h, right? That's what you're trying to do. So let's take this first example. We've got f of x equals square root of x plus 7, h equals 3. What's the first thing you really ought to write down here? Even if you don't know what to do with it, you'd better start out with the expression f of x minus h. So here it is. Now I can write right below the definition of f of x would be a good place to do this. F of x minus h equals. Okay. And actually, I can offset it a little bit, give an even better way. No. Yeah, okay. I really want to do this. I can do it the other way. But then substitute for h, and for x minus h and so forth. I'm going to write it down this way, f of x minus h, then equals what? What's the very first thing you can write for f of x minus h? Well, there are two possibilities. You can plug in x minus h. You can replace x by x minus h, right? And then this will be replaced by x minus h. You get x minus h plus 7. Everybody see that? Okay, I'm not choosing to do it that way, so I had a little debate with myself. But this should be f of x minus h. I really want to see the expression f of x minus 3. Okay, so I want to substitute for h here. And then, okay, now can everybody write out what f of x minus 3 would be? If f of x equals the square root of x plus 7? If you can't, then there are things I need to say. I probably need to say them anyway for people who haven't done much of this. Okay, of course, if you're watching this, you should be following along and doing everything I'm asking the class to do. So, and what I'm really trying to emphasize with the class is I'm giving you a form to use here. Okay. I'd recommend you follow this as an algorithm until you get used to it. It doesn't take long to get used to it. You do a dozen problems and it doesn't take long to write down a problem, okay? So then you're used to it and you can kind of put it in whatever form you think is appropriate, okay? Okay, so again, we're trying to find f of x minus h. Here's a statement of the first case. Here's f of x, here's h. We want to write out f of x minus h equals before we do anything else, because that's what we're trying to find. Then, well, that's an easy step here. H is 3, so it's f of x minus 3. All right. Now you see that x has been replaced by x minus 3. So you replace this x by x minus. That's the square root then of x minus 3 plus 7. And just for emphasis, I'm going to circle the x, and I'll circle the x minus 3 here, and I'll circle the x and the x minus 3 here. You see where these things appear. Okay. Now, some people wrote x plus 7 minus 3, and that's technically correct, but you really want to see the x minus 3. If you got an x minus 3 here, you're going to want to see the x minus 3 over here in the position where the x is. Now, if you understand it well enough, then writing the negative 3 down at the end is kind of okay, but it makes me a little nervous. Okay, it's okay to make me nervous if you know what you're doing, if you really understand this. Then we can, of course, make that into the square root of x plus 4. Since negative 3 plus 7 is 4. Okay, you got to be careful. I've seen people trying to do all kinds of algebra with these things and doing it, just doing things that don't work. Not with this problem, but with the earlier problem. So if you're going to do algebra or arithmetic, make sure you're really secure on it. And you should be very secure saying that negative 3 plus 7 is 4. There's nothing magical about that, okay? Okay, can you do the same thing? Can you follow the same form with this? Write out the steps exactly as I've written them out, except, of course, use the other function. Okay, well, let's look at the other two. Well, let's see, for this one, h was negative 5, and for this one, h was 2. Okay, let's do these in the same format that I did this. Let's leave this up here for a minute. Now, I left myself a little more room to the left here so I can write out my f of x minus h equals. And then underneath my f of x equals 3 to the x, I can say, okay, f of x minus -5 equals. All right. I don't want to do another step, but at the end, x minus -5 will become x plus 5, won't it? Okay, so you got to be careful about that. H is -5. This means we're moving it 5 units in the negative x direction. And then you got to use -5 for h. And when you put the negative of the x minus h on it, you're going to get a +5. And it's not going to work. If you had a -5, just an x minus 5, you'd be moving it 5 units to the right. Okay, now, circle this very explicitly. X here has been replaced by x minus -5. Okay. Here's our rule. Here's the expression we're trying to evaluate. In this expression, x is now x minus -5, so that this x has to be x minus -5. So this is 3 to the x minus -5. So now this x has been replaced by x minus -5. You can check. Same expression here as you got here. X here, x here. Okay? And of course, that's 3 to the x plus 5, which could be written as 3 to the 5th times 3 to the x, and 3 to the 5th is 341. Okay, 3 to the 5th is 343. Sorry, 343. Starting to lose it. So that could be 343 times 3 to the x. Again, that's since a to the b plus c equals a to the b times a to the c. Okay. This is important, and it will be important later. So if you understand it now, kind of lock it in. Okay. It's 20 rules of exponents. Did an assignment on exponents early in the semester. Okay. Again, x is replaced by this. This x has been replaced by this. Okay, so if we do that down here, okay, f of x minus h equals f of x minus 2. You're not trying to do any algebra. You're just replacing x by x minus 2. When you do that, replacing x by x minus 2. When you do that, you get x squared becomes x minus 2 squared. And 1 over x squared becomes 1 over x minus 2 squared. So now we've got 2 x's up here. Each one has been replaced by x minus 2. And of course, we needed to throw in the parentheses because we have to square the whole expression. If x is squared, so does, if x is squared, x minus 2, the whole thing needs to be squared. If we take the y equals x squared graph and move it +1 unit vertically, then the graphs are going to look like what I've got here. The original graph is the same as the one we had previously in the 4x4 square. Okay, and again, the 4x4 square, the graph goes well beyond the 4x4 square, but the 4x4 square gives us a better picture of what happens when we move it. Okay, and it's sufficient to show the properties of the transformations. So if we move it 1 unit higher, then every point goes 1 unit higher. So 1 unit is about this far. So this lower quarter of the square here will go up to here. And this lower corner here will go up to here. And the 0.24 will become the 0.25 if we move it up 1 unit. If we move it up 1 unit, y increases by 1. And -2.4 will become -2.5. Now, what's the formula here? Well, the formula is y equals x squared plus 1. What do you get? So for example, if x is -2, what are you going to get for y? Now work that out. Okay, so it actually took people just a little while to do that. But if you're methodical and write it down correctly and carefully, then if you can find your white chalk, you can, no, I mean, if you, that's it, okay. Yeah, if you do it methodically, you're gonna get y equals, you're replacing x by -2. -2 squared plus 1 equals 4 plus 1 equals 5. Okay, so there we have it. Now, in my class, we've done a lot of things with estimate the coordinates of point on this graph for x equals something, and estimate the coordinates in this graph for x equals something. Your estimate here, if you make an honest estimate, it probably won't be exactly the same as this because your curve won't have exactly the same shape because you're drawing it by hand. But it's going to be very close to one more than what you have here. And that convinces you of this transformation in a way that just following the rule and having open math say, yeah, you got it right, doesn't do. Okay, that's why I emphasize the whole estimating thing and all the stuff we've been doing in my group. But however it's presented in a different class, it's being presented very well. You get the same result. So our rule if that y equals f of x, then shifting the graph h units vertically, we get the graph of y equals f of x plus k. Now that's a formula, at least I know a couple of you know because I've actually seen the f of x minus h plus k form on your paper, which means you're thinking and you're developing some good machinery. But let's understand this one thing at a time, and especially for distant students or students who might not be here today. Okay, so there we have it. That's the rule. So let me ask you to do this. Okay, two of them. Try to imitate the general form I use down here. Start with f of x plus k equals, right? And then work from there. Let me write that. And I guess I should have paused. Okay. Now, if you're going to follow the form of what we did previously, then you write out f of x equals 1 over x, k equals -3. Write it out, then write what follows. And you will write, what are you trying to find? You're trying to find f of x plus k. Okay. Now, what's f of x? It's 1 over x now. Okay. So you're probably wanting to do something like what you did before, but this is a little different. Okay. You're just replacing whatever your expression for f of x is. Okay. So you got f of x and you have an expression for f of x. Nothing is done to this expression. F of x is right there. You can replace it by 1 over x. And then you can replace k. K is -3. So you got a k here. And you can write out literally plus -3. So I replace k by -3. And that's just 1 over x minus 3. Okay. So all you're doing is whatever f of x is, you're doing plus k. Well, after a while, you can get used to this idea. And then you can do it skipping steps. Right now, I'm going to say, write it out like this. Write out what you got. F of x equals the square root of 2 to the x. K equals 12. So, f of x plus k equals 4. Again, f of x is the square root of 2 to the x. You don't do anything to that. So, where you have f of x, you can replace it with the square root of 2 to the x. And then you got the plus k. Well, k equals 12. Here's plus k. Okay, so you're going to just write 12. So here's your 2 to the x, which is your f of x. And here's your k. It's plain old 2 to the x plus 12. And what that does is takes the graph of 2 to the x. It makes all your y values 12 bigger, which means it's going to raise the graph up 12 units. And you know how to do that. Okay, there's another transformation. And I'll just have to mention it quite briefly. Stretching transformation. If you want open math is a vertical stretch of 2. I like to use the word factor. Stretches vertically by a factor of 2. And what that does without being, without running over time. Okay, so here we've got our square. Doesn't look much like a square, but the way I've got it labeled, it is. It's just distorted. Got this square, and we double its height because of the 2 in front. And this point then becomes 2/8 and negative 2/8. We sketch our parabola to that parabola. We sketch our parabola within this. This would, if this is y equals x squared, and it is, this is y equals 2x. Now we can combine all these transformations. And it gives us a great deal of power over the toolkit functions. We can move them any place we want. We can stretch them out. We can compress them. Now, if you're in my pre-calculus class, you've seen that. If you're not, and many students in this course, distant students, and anybody who might not be here today, try to get a handle on that. And the open math assignment, I think, does a pretty good job of explaining a lot of this. They're a little more calculator dependent than I'd like them to be. One should be able to do this by construction. It's better if you can do it by construction by hand sketches rather than plotting points on a computer. Okay, so try to do that. If you're in my class, of course, you've done a lot of that. If you're in other classes, I kind of recommend it's a good strategy.